Hello everyone, welcome back. So this is the part 6 of Quadratic series that we've been doing so far. So in this part, I want to show you guys some graphical insights of the Quadratic series. So what would be it, how it will look like on an XY plane. Okay, so before we go into the quadratic equations again, let's take a look at graphics. So most of the time, when we see an XY planes, so it's just a bit bigger. So I'm gonna zoom it out a little bit, like X here and Y over here. So when we do kind of the equation, we're supposed to put our equation onto the graph to see how it would turns out. So most of the time when we apply kind of it on real world, this is what we do. We just put our equation on the graph so to get a better prediction of what will happen and how this particular thing will turns out. Okay, so this is a graph. So I'm gonna show you two types of parabola to start with. So when we draw kind of the equation, what we get is called parabola, something that has a U shape. So when most of the linear equation go something like this, and it was linear, it made difference according to the slopes and everything. So linear equation most of the time go something like this, and our data will stay on the way in a linear manner. It could be like some multiplication from each other. It could be like the same ratio different from each other. So when we do convert the equation, the difference here is like the equation, the graph of the equation go exponentially. So what we do is it goes something like this and something like this. It has a symmetric relation because when we see a number, let's say, when we encounter a number, which is like 4, it has not only a square root of, I'm sorry, let's say the number is 2, it not only it has a square root of 4, it also have a possibility the square root could be -4, right? -4. So when we encounter something exponent like square, most of the time, even number exponent, it always has two solution, two possibility. As I always say, it has ambiguity. So this is what happened over here. It is always symmetric to each other, and it always have another side which is symmetric to the other sides of the graph. And when it improve, it improves exponentially. So it just doesn't improve in a linear manner, as we see. It's improved in an exponent manner. So it just improve. It's just like how self-developed or population grow. It just grow exponentially rather than linear. So this is how we use this quadratic equation in our real life. Okay, so this is the point of the graph so far. So most of the time when we encounter parabola like this, we will encounter especially two type of parabola. The first type is in the type of U, and the second type will look something like this, something that look like inverted U, right? So when we see, I'm going to show you what is the difference over here later. So when we see this point, when we see this point or that particular point in the parabola, this is what we call vertex or turning point. So this is the point of symmetry, or this is the point that the graph starts turning to the sides. According to the equation, it could go downward or it go upward. When the graph go downward, something like this is what we can see as a maximum point, because the point of the disc could go, lower, lower, lower. So this is the maximum point that it can go. And the minimum could be, infinity, could go to infinity if the equation doesn't have a limitation. So it's also true for this parabola in the U shape. When it's go to upward, you can think of it. it has a turning point, but this turning point is what we can think of a minimum point of the graph, because afterward, all of the point that will go would become bigger and bigger in the value of y, of course, bigger and bigger. And if the equation doesn't really have a limitation, it could go up to infinity, isn't it? Okay, so let's keep this in mind and let's take a look at our equation again. So most of the time when we encounter quadratic equation, it exists in the form of ax squared plus bx plus c. Okay, so when we see the graph, a is like a is like how the graph will turns out. Okay, so if a is somehow bigger than, let's say, 0, it cannot be like equal 0. I have talked about that. A will never become 0. If A will become 0, the equation will become to linear. Okay, so 0, the graph will turns out to be upside, something like this. If A is, let's say, lesser than 0, so negative number, the graph will turns out to be this shape. Okay, so B, what is B stand for? B stand for like this, B stand for like the direction of the vertex. So if B is like positive, the graph will go to the left side. If B is like negative, the graph will go to the right side. Okay, I'm gonna explain it even more in later. So C is like y-axis intersection. So the C will show like where the y-axis will intersect. The graph will intersect with the y-axis. So it's like show you where the graph like intersects with the y-axis. But most of the time when we do something like this, we're gonna use vertex form, to get a better idea of the graph. I'm gonna show you the vertex form later. Okay, so I will go back to the graph again. So let's take a look at the graph again. Okay, so we have x over here and y over here. So most of the quadratic equation are based on y equal x squared. Okay, so we're gonna equal our whole quadratic equation with y. So this is what we call quadratic function. Okay, so I am not going to explain a lot more about function in this series, but you can think function is like an output and an input. Input is like the equation and output is like the solution. Of course, it is a lot more deeper than that, but this is what you need to know right now. So y is like output over here, and x is like the data we put in it. So this particular graph exists in the form of like, it's gonna start 0, because if x is equal 0, y will going to become 0, because 0 squared is 0. So the first point we're going to start here. And then let's think, if y is, let's say, 1, okay, it looks better now. So y is equal 1, the graph will be like, the graph will stay in 1, comma 1, because 1 time 1 square is 1. It also true for negative 1, isn't it? Because negative and positive has the same roots. A number has always have negative and positive root. If this is going to become number 2, positive and negative 2, the y will become 4. And then, if it was 3, it will become 9, and so on. So a graph will look something like this. So this is the basic graph of quadratic equation. Every quadratic equation will come in the things like that. When we put a negative number, let's say, as I said before, the value of a, the coefficient of x squared is become negative, the graph will be inverted, something like this. All right? And if we put some number, let's say if we put different coefficient 2 or 3 or 4 in front of in the place of a, the graph will go wider. If the value is like, smaller than 1, the graph will become wider, and this value is greater than 1, the graph will become steeper and something like that. Okay, I'm going to show you guys about this in later. Okay, so this is how it all turns out. So you get the ideas here. So I'm going to show you how the manipulation in graph come in here. Okay, so before we go into the graph furthermore, let's just take a better look at the manipulations becoming over here. So let's say the graph we have so far is y equal x squared. And what I want to do is here, it's like I want to put, let's say +1. I want to put one more number. I want to, put a graph a step furthermore in one more coordinate in the y-axis. What I have to do is, what we know so far is x squared is y itself. So if I want to add another value, I'm going to put positive ones over here. So if I'm doing something like this particular graph, the orange one that I have drawn, will come up to 1, right? This is what we do here, up to 1. So if I said like something like, instead of +1, I'm going to put -2. So I'm going to subtract 2 value over the y-axis. So it's going to look like, my graph will look something like, okay, I'm going to erase this one. My graph will something look like this over here. Because I subtract 2 units, let's say here is the 2. I subtract 2 units, so the graph will descend to -2. So this is the point what we call vertex over here. Okay, so I want you to think like some manipulation do outside of x squared. This is x squared. Some manipulation outside of x squared. This is meaning that we are manipulating y-axis. So the difference will be in y-axis. So what if we want to do the main data? We want to do manipulation inside x-axis. So when we want to move things along the axis, what should we do is we're going to, put some number beside x within the square. So it will look something like, let's say y equal x. And instead of doing outside along the y-axis, we're going to do inside. So it means like we're doing something along the x-axis. So let's say I want to subtract 1. Okay, so by meaning of subtracting 1 along the x-axis is like putting one more move along the y-axis, because when we put this -1 other side of the equation, it will become +1. So this is what we've been doing. So it's like, you can think, if you want to do in a shortcut manner, you can think of like subtracting 1 is opposite. So the graph will go along this main graph over here, will go along 1 unit to the positive sides here. So the graph will start instead of here as well. Let's say instead of like subtracting 1, what you do is adding 2. So adding 2 in opposite manner, we can think of like moving the graph along the negative axis 2 units. So the new graph will look something like this. So this is what's going on here. Okay, so let's say what I do here is I subtract my graph in the x-axis. I'm gonna subtract 2, so add in 2 unit in the x-axis, and then I'm gonna subtract 3 more units along the y-axis. So what is going to my graph? I'm gonna erase all the other graph, but I'm just gonna put this main graph over here, which is y equal x squared. So what I do here is I subtract 2. It means like I'm gonna move the graph 2 units along the y-axis. 2 is over here. So I'm gonna move here, and then I'm subtract 3. So I'm going to descend the whole graph along the y-axis 2 more units. So my new vertex will be staying here. It will look something like this. Okay, this is what we've been telling so far. So when we want to draw a graph particularly, we're supposed to find where the vertex come. Okay, so I want you to find 3 points when we try to, draw a graph with a quadratic equation. What we have to do is first find a vertex form. So we're supposed to find the vertex form to see where is the turning point and to get a better ideas of, like, it could be a measurement or minimum points. And second, to see the coefficient of x squared, to see a. So the coefficient of x squared is negative, the graph will go downward. If the coefficient of x squared is positive, the graph will go upward. So we have to see how the graph will turns out. And for the third set, let's see intersection. If y intersection is here, we're gonna find y intersection. If the graph has x intersection, we're gonna find x intersection. In this way, we are able to draw the graph, with the foundation of y equal a square graph. Okay, so let's see. So to get a better ideas of what's going on here, we have another form that we can write under the equations. This form is what we call vertex form. So by writing the equation in a vertex form, we're gonna get a better ideas of how the graph would turns out. But most of the equation will not come in a vertex form. So I'm gonna start by drawing the equation with a standard form. Standard form is ax squared plus bx plus c. I'm gonna introduce about vertex form later. So let's do something with standard form first. Okay. Okay, so I'm gonna, I'm gonna erase everything on my plane. Okay, so here's a recommendation. If you're just trying to draw some graph, I will recommend using graphical paper, which is, it's not expensive at all. You can just buy anywhere where they sell the books and, like exercise book and everything. If they sell books, most of the time they sell graphic paper. So I really recommend for you to buy some graphical paper for you guys to be able to use it easier. Okay. So this is the standard for over here. Y equal ax squared plus bx plus c. So to get a vertex form, it's already have another equations over here. This equation says vertex form is like kind of exists in the form of y equal a x minus 6 the whole square plus k. Okay, so in this, I feel like this equation is a lot easier for us to understand, the upcoming of a graph, how a graph will turns out to be. So when we see a, by looking at the coefficient of a, we can see like how a graph will be upside down, or like it will be downward, like upside down or downward graph. And as by looking at x, we can take a look at how a graph will move along the x-axis. By looking at k, we can see how a graph will turns out along the y-axis. So our vertex will stay in the form of a comma k. So if we encounter the graph in the form of ax squared plus bx plus c, to find the vertex, to find the point of the vertex, to find where could our graph could exist, what we can do is we can compare these two formula over here. So how we can get the vertex form, we can find a way to find the vertex form, right? Okay, so I'm gonna separate out the later. I'm gonna separate out this one. So it's going to be look like a squared minus 2xx plus x squared plus k. right? So it will look something like ax squared minus 2axx plus x squared plus k. So according to our understanding of the standard form, we can take a look this form at this part as a constant part, and this part as, you know, the value of x to the power of 1 part in this part at ax squared. So ax squared is basically equal to ax squared, so we don't have to do anything anymore. So in terms of bx, it will look something like bx is equal to axx, isn't it? So to find x, which is a vertex, as I said earlier, x is the vertex over here. So to find the vertex, what we have to do to b is we're going to have to do x h equal b by 2a. We're going to get a summarizations over here of x becoming 2a because x will get divided out each other. So h will become b by 2a. So to our understanding, to find the point of the x, we're going to have to find the vertex from b by 2a. So if we have encountered the standard form, what we can do is to find the vertex form, we're going to use this formula over here of h equal b by 2a. Okay, so let's do it. We're going to use x equal b by 2a, and then we're going to put this value of x within the equation. We're going to get the value of y. So we're going to get x comma y, and we're going to get this vertex form that we're saying. Okay, so it will be a lot easier. So let's say we have an equation that looks something like, okay, y equal a squared minus 4x plus 3. So according to a formula, we're supposed to find this is a, and which is a is equal positive 1, which is greater than 0. So it means the graph is upside. Sorry, the graph is U-shaped. The graph will, go upward. And then we're gonna find a vertex. So for vertex, we have to find minus b by 2a. So it's going to, the vertex will look like negative 4 by 2, 1. So the vertex would be 2. Okay? So if we put 2, we put 2 over here and 2 over here, it will become, so 4 times 2 is -6. We have 2 into 2 and positive 3. So the positive 5, -6. So the vertex of y would be if a is equal to y equal -1. Okay, you got the idea how -1 turns out. So what we have is vertex equal 2, -1. If you want to, you can just, what you can just do is you can also separate this part into a complete square, what we have talked about. So this is another way around to find the vertex over here. Instead of like doing this vertex formula, what you can do is you're gonna make a square minus 4x, and then we're gonna do complete square. So it's going to be like to make it complete, it's going to be like plus -4 the whole square plus 3 plus -4 the whole square. Sorry, it's not a -4, it's -2, right? This is the complete square for. I have talked about this in the late former video, so you can just take a look. So our equation will go into a minus 2 the whole square plus, sorry, yes. We're gonna have to subtract this part, I'm sorry. So it will become -1. So y-axis -1, x-axis is -2. It means 2 units in x-axis, -1 unit in the y-axis. Okay, so let's come back to the equation. So 2 units to the y-axis mean 2 units over here. And then -1 unit mean -1 downward, right? And then we have c over here. C is +3. So what it means is like the intersection of equation should be +3. So this is the intersection over here. This is the vertex over here. Line of symmetry is at this vertex form, particularly. Line of symmetry equation is like at x. This is where the line of symmetry is going on here. So we have y intersection in this over here. So the graph will look something like, the graph will look something like, okay, so the graph will look something like this. According to its symmetric, it will look something like this. Okay? It also have x intersection. What is this even mean? What is this supposed to mean? So what this mean is like this particular graph is also factorizable. You can just factorize this into h minus 3h plus h minus 1. I have talked about this in a former video. So it means like when it's come to graph, intersection means answer. So this is 1, 3. So in this way, you can just, you can just draw a graph according to a vertex form, complete in square, or the combination of this I was shown before. So I'm going to show you a few other example in later part, in part 7. So this part, this is the 7. This part is the 6th part, part 6. So in this part 6, I've shown about the vertex form and how do we, construct a graph over the XY plane. So it might be a little bit harder for you to understand. I really understand it. This subject is just a bit confusing to understand. So I'm going to show a few more examples to give you a better idea of it. So this part is for now on. This is all about this. I'm going to share more. If you really like this channel, if you really like this kind of video, please think about giving this video a like and subscribe it if you want to see it more. And if you're interested to elevate your math skill, if you want to get a better idea and foundation about math, you can join my Math Elevate online program that will start in July 28. So I'm in July 18. I think it is July 18. So I will give a link about the program also. So this is all for now. Thank you so much. See you later.